Hello, sir. Um, I'm doing an assessment on angular momentum and chapter 11, and I'm solving a problem where a low mass rod with a length of a certain meters has a metal ball of mass of certain kilograms at each end. So the center of the rod is located at the origin, and it rotates in the YZ plane. And every rotation for the rod takes about 0.5 seconds. So the first part, they ask us what is the momentum of the inertia of the object, the rod plus two balls. So like before solving that, I found that these are all the given informations: the length of the rod 0.3 meters, the mass of the metal ball which is 0.7 kilograms, the period of the rotation 0.5 seconds, the angular speed of the rotation. So it's W is equal to one revolution over 0.5 seconds. So that's how long it takes. So I changed this to radians, so it's easier to work with. So one revolution over 0.5 seconds times 2 pi radian over one revolution. So revolution cancel. By solving this, I get a value of 12.54 radians over seconds. So with the question we're about to solve, what is the momentum of inertia of the object? So this is the formula I started with. I is equal to ml square. So L is the length and this is the mass. So we need to know what is the momentum. So I need to know the I total is equal to the inertia. Total inertia is equal to the first inertia of the first ball plus the inertia of the second ball. So we know inertia is equal to ml square. So for this right here, so if you think about it, it's at the center, and it's from the origin to one ball, so it's basically the half of the original length. So it's the kind of like a radius, so it's L over 2. That's why I have L over 2 here instead of L. So first ball and the second ball, and by simplifying it further, I got 2m L squared over 4, and so I total is basically 1 over 2 ml squared. The 2 and 4 cancel, so 1 over 2. So that's how I got this. So total inertia is equal to 1/2 ml squared. And it's basically plugging in now. 1/2 m. We know the mass to be 1.7 kilograms, and the L length is 0.3 meters square. By solving this, I get a value of 0.0765 kilograms meters square. So that is the moment of inertia of the object. So part B asks us to find what is the rotational angular momentum of the object. So the rotational angular momentum is nothing but L is equal to IW. We just found the inertia, and so here it's nothing but I, which we found here, so 0.0765, and W is like the angular speed, which we found before, the revolution over seconds, 0.5 seconds. So that's this right here. So by multiplying them together, I get a value of 0.961 kilograms meter square over second. So that's the rotational angular momentum of the object. So the rotational kinetic energy of the object is nothing but K is equal to 1/2 IW square. So here I is the same thing which we found before, the inertia 0.0765, and the angular speed is 12.57 square. I don't know if you can see it, it's square. And by solving this, we get 6.043 joules. So that's the rotational kinetic energy of the object. Thank you.